Level of detail, LOD. Level of detail, or LOD, reduces the complexity of objects as they move further away from the camera. How it works? Developers create multiple versions of the same object with varying levels of detail. High detail models are used for close-ups, while simplified versions appear at a distance. This reduces rendering load without sacrificing visual quality. Example: The Witcher 3. White matters. LOD ensures games look great while maintaining smooth performance, especially in open-world environments. Culling. Culling prevents the rendering of objects that aren't visible to the player. How it works? For some culling, only objects within the camera's field of view are rendered. Occlusion culling. Objects blocked by other objects are drawn. Backface culling. Surfaces facing away from the camera are ignored. Example: Horizon Zero Dawn. White matters. Culling saves processing power by forcing only what the player sees. Textual streaming. Textual streaming dynamically loads textures based on player's proximity and viewpoint. How it works? High-resolution textures are loaded only when needed, reducing memory usage. Unused textures are unloaded in the background. Example: Call of Duty Warzone. White matters. This technique balances visual fidelity with performance, especially in large, detailed environments. Baked lighting. Baked lighting pre-calculates light interactions and stores them in textures, avoiding real-time calculations. How it works? Lighting for static objects is baked during development. Dynamic lighting is used sparingly for moving objects or characters. Example: Uncharted 4. White matters. Baked lighting achieves realistic visuals without overloading the GPU. Mesh instancing. Mesh instancing reuses the same geometry for identical objects, like trees or rocks, to reduce memory usage. How it works? Instead of creating multiple copies of an object, the engine renders one instant multiple times. Position, rotation, and scaling are adjusted to avoid repetition. Example: Minecraft. White matters. Instancing reduces memory overhead and improves rendering efficiency. Resolution scaling. Resolution scaling dynamically adjusts the game's resolution to maintain constant frame rates. How it works? The same renders at a lower resolution during instance scenes and scales up to match the display resolution. Techniques like NVIDIA's DLSS or AMD's FSR are used AI to upscale the image. Example: Cyberpunk 2077. White matters. Resolution scaling ensures smooth gameplay without compromising too much on visual quality. Physics optimization. Physics systems are optimized to calculate interactions only when necessary. How it works? Simplified physics simulations are used for background objects. High-detailed physics are reserved for critical gameplay elements. Rigid body physics or particle systems are optimized for real-time performance. Example: Half-Life 2. White matters. Efficient physics keeps gameplay smooth while maintaining realistic interactions. Dynamic LOD and asset streaming. Dynamic LOD adjusts not just models but also textures and effects based on in-game activity. How it works? Textures, shaders, and particle effects adapt to the player's approximately or focus. Dynamic systems ensures high fidelity during critical moments and scale down in less demanding scenes. Example: Red Dead Redemption 2. White matters. Dynamic systems provide a seamless experience while conserving resources. AI optimization. NPC behavior and pathfinding are optimized to avoid unnecessary calculations. How it works? Idle NPCs or distant enemies use simplified AI states. Pathfinding systems use grid-based or hierarchical methods to reduce processing. Example: Halo. White matters. Efficient AI ensures large worlds feel alive without compromising performance. Memory management. Proper memory management prevents performance drops or crashes. How it works? Garbage collection removes unused data from memory. Objects pooling reuses resources like projectiles or particles. Example: Unity and Unreal Engine-based projects. White matters. Good memory management ensures constant performance, especially in resources-heavy games. Watch this video to discover FPS game mechanics you need to know as a game developer.